Good morning to one and all. I am Prakash. I am from SRM Institute of Science and Technology, Chennai. So I'm going to present my research paper. So the title is Deep Learning Approach for Predicting Bone Disorder Using DenseNet. And my colleagues, Dr. Kottilingam sir and Dr. Sathish Kumar sir. So my contents of my paper are abstract introduction, bone mineral density and motivation, and model design and architecture, model implementation, result and analysis, conclusion and future work and references. So my abstract, osteoporosis is a medical condition that affects the structure and strength of the bones. So actually the bone will be like as the honeycomb structure. So bone scan, image, observation study requires multimodal algorithm for finding the factual errors in the assessing accuracy on diagnosis. Key objective is to provide a critical review on of the main artificial intelligence based systems for detecting populations at risk of osteoporosis or fractures. So skeletal deformities, fractures, twisted knees, inherited bone defects, and other bone disorders affects millions of individuals as a result of a variety of bone disorders. In our research, architecture and concept of the deep learning algorithm we use to detect bone density were also discussed. Earlier I told that the honeycomb will be having the spaces means that, so it will be called as osteoporosis. So the healthy bone looks like a honeycomb structure. So it will be differed from the honeycomb structure like having a spaces means that will be as a osteoporosis. So the introduction of my paper. So low bone density and bone tissue damage characterize osteoporosis, which leads to increased bone fragility and fracture risk. People with osteoporosis may not develop any symptoms and disease, therefore it is called silent. So a fractured bone is also the first symptom of osteoporosis, which is why it's often known as a silent crippler, since patient does not realize they suffer from it until the time runs out. So by 2050, the global incidence of hip fractures is anticipated to increase thrice in males and twice in women. So this is a thing. So healthy bones like a honeycomb structure. So the differs. So like what is osteoporosis and severe osteoporosis. So like the images I have given here. And bone mineral density, from this only we are finding out whether it's a healthy bone like that. So BMD is a bone mineral density, has been used to diagnose osteoporosis since 1994. So World Health Organization defines osteoporosis as a BMD of 2.5 or more, standard deviations below that of a young healthy woman. So it means that, so above 2.5 means that they're having their osteoporosis. So as T-score between +1 and -1 considered as normal or healthy. A T-score between -1 and -2.5 indicates that low bone mass, although not low enough to diagnose with osteoporosis. And motivation. So motivation of my research. So bone and joint disease can lead to chronic pain if not treated properly. So bones at risk as a result of delayed disease diagnosis, which contributes difficult and inefficient existence. So bones are essential for mobility and often serves as a cog for the internal organs. So as a result of late diagnosis, not only bones but on other organs at risk. So as the world evolves, now finding on bone disorders emerge, increasing the risk. So to combat this, will develop a machine learning algorithm to recognize and diagnose different bone disorders based on bone density. Wrist, elbows, knees, ankles, and finger joints are all examples of healthy joint that allows body to move freely. So using a convolutional neural network, a predict bone age assessment can be automated by the hand radiograph. So we propose a regression convolutional network to be specific to assess the age of the bone using the hand radiographs. The first attention module is used to process all the images present and generate a fine attention map, which acts as input for regression network. We are introduced to deep neural network and discuss the current achievements in the sector, such as detection, classification, and segment in the image analysis. Improved and optimal bone disease prediction using the risk factors. The main purpose of the research is to analyze electronic health records and forecast the risk natures that occurs in the human body using different forms of offline features. The objective of artificial intelligence on the identification of risk groups for osteoporosis, the fundamental frameworks. So this is my objective. So the fundamental frameworks that uses the computerized reasoning to distinguish the danger of osteoporosis are cracks. So the first thing, and then the framework considered for examine where those will satisfy the accompanying precautionaries, scope of inclusion, minimal expense, and ability to recognize more huge physical elements. The aim to gather and describe the main techniques used to point out the risk groups for osteoporosis and recognize their trends as well as their challenges. So the model design and architecture. So here I have taken the Mura dataset, so which consists of the X-ray images. So the having the musculoskeletal radiographics, more than 1.8 billion in the world are affected by the musculoskeletal disease, so which are leading cause of long-term pain and disability. DenseNet is a network design in which each layer feed forward connected to all other layers. Previous layers feature maps or read as separate inputs for each layer, while the layer features maps are taken on as inputs for the future levels. So we suggest a routing pattern to increase information transfer between the layers. We create a direct ties from the any layer to the layers below it as results. So we have taken as previous layers of maps y0 up to y1 minus 1. Like that we have taken. So they're having that architecture, they're having a pooling layer, growth rate, transition layer, batch normalization, and dense block. Like that we have done with the 169 layer of convolutional neural network. So in the study they're having the elbow we have taken. So the arithmetic mean of the output probabilities we are getting. So the abnormality also we have find it easily. So the next thing is model implementation. The Mura detection model is binary classification assignment where the input is the upper extremity sample with one or more views. As a result, it has binary marks y0 and 1 showing the study of nature. It means the normal or abnormal respectively. So this is a thing. And then we gather de-identified HIPAA complaint photographies from Stanford Hospital. So a large data set was downloaded, the elbow and then finger, thumb, side, and then humerus, back, and then wrist are 7 normal upper extremity radiographics research forms. So the board certified that radiologists from the Stanford Hospital manually labeled each sample as a normal or abnormal during clinical radiographic analysis in the diagnostic radiography department. The dataset was divided into 2 parts: training 2,300 steps and validation 199 steps. In the article, we suppose this observation and introduce DenseNet, a feed-forward network that contains each layer to be the next. So each layer uses the feature maps from previous layers as inputs, and each layer's feature maps are used as an input to the all subsequent layers. So finally, the resultant analysis, it observed that our model takes a total of 15 epochs, where each epoch takes a total of 730 seconds with 2,300 training steps. Through every epoch, our module accuracy has increased. Model accuracy is 83.38, validation accuracy is 78.20%. Model loss is 0.4198 validation, and then validation loss is 0.5008. We also calculate the model accuracy by using another method, finding by evaluate generator. So the accuracy is 77.73% and loss is 0.49 and up. So via this method, so our main aim was to increase the accuracy of dataset containing shoulder images. So to create a standardized model, this can be run for all above images present under the Mura dataset. During our experiment, we made sure to prevent overfitting and underfitting of data and try to make the model as real-time as possible. So the result, so it can observe that the epoch increases the training accuracy increases while using the training data set, and it can be decepted using the red line. The blue line represents the accuracy where we achieved after validating our model. As the number of epochs increases, the accuracy increases, and sometimes there is also a fall represent the real-time nature of our model. So this is a graph for the accuracy curves. So we can conclude that as the number of epochs increases, the model loss decreases, which is good thing because the model loss should be a less possible. As represented in the below graph, the blue line depicts the model loss which occurs during training, and yellow line despite the model loss which took place while performing testing. This is a graph for the model loss. So the conclusion and my future work. So we propose a conclusion neural network to process X-ray image. That means that abnormal or normal bone. DenseNet has been seen to be an appropriate model for our use, which helped us improve the accuracy of our model. The model achieved its accuracy in provided period of 1.5 months, months of continuous research, training, and validation. So working on X-ray images can also help us learn the explore of study various issues and disorders and infection, etc. So using more powerful hardware, we can also increase the efficiency of our model. It would be enabled to carry out the experiment training and testing more expensively. So these are my references. So thank you for your opportunity. Thank you all.